There we go.
Okay, now it's good.
Good evening. I'm Randy Enkin, and it is Monday, March 9th. And I welcome you all to this week's Astro Cafe. I am not in Fairfield Community Center because I'm coming off a cold, but I do have the cookies that I was going to bring. So you guys in the Fairfield will have to wait till next week for these lovely chocolate fudge cookies. Um, I have I talked myself on daylight saving time, Jeff Pivnick on some more about Artemis, Natasha about the Greenland telescope, David Lee about our um, equipment um, warehouse, and we're going to talk about the International Astronomy Day. Anybody else in particular?
Randy,
Any images?
Randy,
Yes, Natasha.
Natasha, I'll have to wait till next week on the Greenland thing.
Oh, okay. That's fine. Anybody else have something fun to talk about? No photos? No
I could
ask.
I could mention something real quick. Just
You do that, Dave.
sure.
Okay. Um, and then there'll be some announcements. Uh, so Jeff, I'd love to start with you. Is that okay?
Absolutely.
Thank you.
More than ready. Um, Biggest challenge is, of course, just getting this up, but give me a moment. Perfect. You see that okay?
It's perfect.
Okay. So last week I was talking about Artemis and the wet dress rehearsal, and there was a corollary to that that I just didn't get time to cover. So just to walk you back through it, because this is how I came at this, looking at Artemis and the issues that had arisen with Artemis. And as we saw with Artemis, both the first and second wet dress rehearsal really, I mean, they tested a whole bunch of things successfully, but the issues that arose had to do with the use of the cryogenic fuel. Cryogenic means just really, really cold, and it's sort of the liquid hydrogen is down near absolute zero. So it causes lots of problems, causes shrinkage, causes seal issues. So in the first one, there was a problem with shrinkage of the main tank, and then the seal interface between the loading mast and the tank was asymmetric, so they weren't able to load it properly. And with the second one, it had to do with the second stage or the interim cryogenic stage. They had problems with the helium that they had on board that they needed to use to maintain pressure in the hydrogen and oxygen tanks for the second stage. So two failures. It's a really complex system. I mean, it's not surprising that there's issues with it because it's a brand new system, although that kind of system had been used in other craft. So it got me thinking about firstly, cryogenic fuel is really difficult to use. And, your first question you say is, well, so why are they using it? Well, there's some really good reasons to use it, and it has to do with a lot of trade-offs. Perfect. It's the best thrust, sorry, it's the best um, um, it's the best use of fuel that exists with any of the fuel combinations now. As far as the efficiency goes, it's not as dense, so it doesn't weigh as much. Although the trade-off is it's bulkier, so you need a larger tank. It burns pretty cleanly, and most critically, it's a reliable restart in the vacuum of space. Although you'll see that they make other decisions when things are absolutely mission critical. So it led to the next question. So how and why Are they choosing different fuels? I'm going to just try and get rid of this. That's not very successful.
Doesn't seem to be affecting us.
Yeah, it's affecting me though, so I can't see the screen. It was a good try. Anyway, let's see if I can just get rid of it. Yeah. So anyway, do you see that okay?
Yes.
Okay, good. So how is it that they choose different fuels for different missions? And I went through the manned missions, and you know it's really interesting because everything's trade-offs. You know, what's it cost? What kind of liftoff? What kind of liftoff weight do they have to take into orbit? What are the requirements of the mission? What fuels are required for mission critical functions? And you'll see that varies. Human safety, you know, of course, is a huge concern and consideration. You know, they also come into expediency. What's practical? What's possible? What do they have experience with? What's safe? What's available? You know, what's cost effective? So I want to just get this slide on, you know, for documentation purposes. But if you go through the different missions, different combinations of fuel are used, and I'll just walk you through them because they were all used for different reasons. Mercury missions took place in 61 to 63, Gemini 65 to 66, Apollo 68 to 72, and then finally the shuttle 72 to 2011, and we're now coming into the era of Artemis. So I'm going to go back and forth with this slide, but I think it's more helpful to see the comparison of the different kinds of rockets that were put in space. And these are the first ones. So you have with the suborbital Mercury, they used the Redstone rocket, and then the orbital Mercury used the used the Atlas rocket. The Gemini program used Atlas 2, and of course Apollo used the Saturn V with its stages. So just to walk you through those, and so you can just get a sense of how these decisions are made and why they are. So you start with the suborbital Mercury missions. That's the Redstone rocket, and most of these fuels will have a fuel and an oxidizer, and in most cases, liquid nitrogen was used, or sorry, liquid oxygen (LOX) was used as the oxidizer. The fuel in the suborbital Mercury program was just alcohol. Alcohol was used. It was obviously in the very early stages of the space program, and much of the space program, as you remember, was built on the German rocketry from the Second World War. Alcohol had been used in the V2 rockets, and that's what they used as they were developing the Redstone rockets used for the suborbital flights. Mercury then moved on to the orbital flights, which of course had more requirement for the orbital flights. They use something that's referred to as RP1 or refined. Do you see my arrow here?
Yep.
RP1 or refined petroleum 1, or other sites will say it stands for rocket propellant 1. But anyway, it's kerosene. You know, complex carbohydrate, but nonetheless, you know, useful, cheap, available, stable, can be used as a liquid at room temperature. It's got a high density, so basically the fuel tanks can be smaller, and obviously the rocket at that point they were just getting going with the missions, so they used that's what they used for that mission. Come to Gemini now, and the Titan II rocket is used. They changed the fuel for Gemini, and you know, for a couple of reasons. They used Aerozine, which is basically hydrazine. Um, Hydrazine, when combined with the oxidizer, and they use nitrogen tetroxide as the oxidizer, is considered a hypergolic fuel. Hypergolic is a term NASA uses for basically ignites on contact. So there's no need for an igniter. There's no difficulty with getting an igniter to work. It's a very simple system. It avoids a lot of the technical difficulties that other rocket engines use. The other thing with hypergolic fuel is it's incredibly reliable because you just dump the two together and it ignites. There's no need for any other process, no need for any other breakdown. So the big thing with Gemini and Titan 2 that was used is that Titan 1 was a ICBM missile. They use the technology from that. It's storable. It's storable at room temperature, and it can be stored over a long period of time. The downside of this particular hypergolic fuel is it's toxic, corrosive, and carcinogenic. So those handling it really need to be very careful of the handling. Then we moved on to the Apollo program with the massive Saturn V rocket. And Saturn V you needed to just generate enormous amounts of thrust. Saturn V also used the RP1 or the kerosene fuel. So efficiency isn't as critical with getting something off the Earth, but thrust is critical. So the decision made with Saturn to get that huge rocket up was to use kerosene. Kerosene is of course combined with LOX, and that was the stage there. High density, it's stable. Again, because it's dense, the fuel tanks can be smaller and generates a lot of thrust. Now, when you move down to the second and third stage of the Saturn V, so that's the S2 and the S4B that were used, they then, because they're now approaching or in Earth orbit, or at least away from gravity, there they used liquid hydrogen and LOX. So same system in a different manner that we're now using in Artemis. So this is one of the first uses of it. And they went through several, well, as you recall, several flights, first unmanned and then manned in Earth orbit, just working out all the kinks. Just as a reminder, with the liquid hydrogen and the liquid oxygen, which is the very, very cold fuel. The handling is really critical, and it has to be maintained at temperature. It does have restart reliability, which was critical for the especially for the third stage, which was necessary for translunar orbit, or sorry, translunar insertion. The other thing with Apollo is, of course, the other critical rocket systems were the Lunar Excursion Module and the Service Module, two critical firings. Obviously, the Lunar Excursion Module needed to break landing on the moon and then take off from the moon, and that was a situation in which there could be no error, and it's not only mission critical, it's life critical. And the decision in that situation is to use the hypergolic fuel, so hydrazine and the nitrogen tetroxide. And it was also used in the service module because that was necessary both for the firing behind the moon on the flight back to Earth, and then also for braking to return to the Earth from Earth orbit. So then we moved up into the shuttle. And the space shuttle was the first of the rocket systems that used solid rocket boosters along with the combination of the liquid hydrogen and the liquid oxygen. And I mean, you recall the huge orange tank filled with hydrogen. And most of us are used to the two massive solid fuel boosters and the three large engines on the shuttle firing into orbit. Interestingly, as I read about it, That system, even when the solid boosters fell off and the shuttle continued firing its liquid hydrogen, excuse me, its liquid hydrogen and its liquid oxygen, that wasn't sufficient to achieve high Earth orbit. They also needed the burn of the other two engines, which I didn't really appreciate existed on the shuttle as well. And you can see them basically at 60 degrees and 300 degrees from the central main engine at the back of the shuttle. These are part of the orbital maneuvering system, and they were necessary for final insertion into high Earth orbit. They were used for orbital changes, and they were the retro rockets that were used to break the shuttle to return to Earth. So all pretty mission critical functions, and the maneuvering system here also used the hypergolic fuel, the hydrazine and the liquid oxygen. Then finally, we come to the Artemis system, and we've talked about the Artemis system before, and this just breaks down firstly the core stage, the main stage, which is where the liquid hydrogen and liquid oxygen are used. It has, of course, two solid boosters attached to it, four engines that fire, and they use the liquid hydrogen, liquid oxygen. The second stage also, and you can appreciate, I think it's better here. The second stage also uses it's smaller. This is the interim cryogenic stage, uses a rocket which burns the liquid hydrogen and the liquid oxygen. The final stage, though, of the rocket system, the Orion spacecraft itself, and you see it better here, the picture at the lower right uses a different system, and this again mission critical. So it uses hypergolic fuel, it uses hydrazine, and the nitrogen tetroxide. This is necessary for insertion into the translunar, or for the translunar insertion. The mission will use a slingshot orbit around the moon, so it doesn't have to fire behind the moon, but it's also used as a braking rocket when Earth orbit is achieved for deorbiting. So again, absolutely life critical, and that's where the hypergolic fuel is used again. Show you just the comparison of these two last systems, which really are mirrors of each other with the large tanks of the liquid oxygen, liquid hydrogen, and the solid boosters. Somebody had commented before that the solid boosters from the shuttle program were also being used for the Artemis program, of course, with an addition. They're a little bit bigger. For completion, just to take you through it, Starship, which is Elon Musk's coming craft, and Blue Origin, which is from Jeff Bezos, both are using methane. Methane is a very simple hydrocarbon, very clean burning, and that's necessary for reusability of the craft. It's also higher density, smaller tanks, easier storage, and has a higher melting point, so that it can be maintained as a liquid at lower temperatures. I mean, we're talking a minus 880, but we're not approaching absolute zero. Yeah. Starlink, I guess the other thing to know is Starlink, which is the Falcon 9, uses kerosene. They're back to the RP1, or the refined petroleum. So that was just finishing up my talk from last week. Any comments or questions certainly are welcome.
Very interesting.
Do they run at different temperatures? Do you have to worry about the materials that these motors have to contain the fire?
That's a really, really good question. And I didn't look into that. And I mean, certainly with the liquid hydrogen and liquid oxygen, they needed to ensure that the engines were cool enough that the initial um, introduction of the fuels didn't damage the engines, but I didn't look into what temperatures they actually ran at, in Randy.
Any others? Well, thank you so much, Jeff. That did
Yeah,
answer a
thank you, Jeff.
bunch
That
of
was really good.
questions.
Yeah, no, it was very interesting looking into that.
Sorry, I was a little late there, but I'm curious, what do they use for ignition on the like to actually light the candle on the hydrogen and the methane systems, you know?
So you're talking again, really good question. All of the other fuels require an igniter or an igniter system where the two fuels are mixed and then you introduce an igniter. I'm not sure of the specifics of the ignition system, but all of the other fuels, the ones that combine a fuel and an oxidizer, do require an igniter.
Hopefully it's a better system than that's on my barbecue.
Yeah.
Yeah, I know. I always have to hit mine quite a few times, and I always have that feeling as I'm re-entering the Earth's atmosphere.
Yeah.
Well, it was interesting. That's why the hypergolic fuel is used, for those critical situations. You just dump them together and they ignite by themselves.
Yeah, I was wondering if maybe that's how they did it, because the SR-71 had a hypergolic igniter for their turbines, and it occurred to me that maybe that's how they're doing it, because you'd want something that's extremely, either have like a pilot light, like your hot water tank, or use a hypergolic that is going to guarantee to start the engine.
Yeah, no, interesting point. It's a very good point in terms of how they do it, and the mechanics would have to be precise. The hypergolic fuel itself, I mean, is storable. I didn't see any mention of the, tanks holding other fuels there, but certainly it's possible.
All right, thanks.
There's another propulsion, which I think they use just for the little bit of correction, like on Gaia, which had to be very, very precisely, it had to rotate at exactly the right speed. And there they just pushing out gas. I think there's no attempt to ignite it. It's just that transfer of mass from a gas tank to the outside.
Just relying on the fact that every action has an equal and opposite reaction.
Yeah.
Yeah.
Although that's a whole other rabbit hole to look at, is all the ways that they do these adjustments.
Well, yeah, certainly space, and the lack of having to overcome, either friction in air or gravity, it really changes the kinds of systems and the kinds of considerations.
Mm-hmm. That was cool. Thank you so much, Jeff. Now, I'd like to talk about our wonderful eclipse last week. So, who all was there? I know we had David and Laurie and Kevin and Alex. Was anybody else up at the hill, or did anybody try to watch it from home?
I try to watch it from home.
So, I do have one photo. Maybe somebody has another one, but let me just share. So David Lee had his camera out, and there it is. See? And at midnight when I left home, or midnight 30, it was a bit of cloud, but damn it, by the time the actual eclipse was coming, I mean, you could see there were windows through the cloud and you could actually see the bite taken out of it. But my hope of being able to recognize when the shadow came to different craters wasn't possible. I could see, um, like, oh, what's that lovely one that I like? I'm just blocking on the name right now, next to the Mare Crisium. It was very clear at sometimes, but not when the shadow, the umber, was going across. Anyway, it was actually a very fun time. And Lori, how many people were up there? Do you know?
Oh, I would say probably about 60 to 70 people
That's
came out.
wild. And
Yeah.
it was very
Yeah.
good natured, and there were nice snacks and treats. And in the conference room, who was it who gave a talk while
Oh, Ruhi
it was
Jan
Ruhi,
Mohammed. Yeah.
right? And then they invited me to give a talk, which I did at 3:15 in the morning, and people were keen. I gave my crater timing talk to the people, and they were very attentive. That was a first for me.
What I
Mike-
noticed was the people that were there were all just a little bit younger. Like there weren't really a lot of older people there, or really there were a couple of younger people, but they were all kind of mid, mid group. So they were the ones who could stay up, I guess. I don't know.
Mid 50.
Yeah. Yeah.
Mike Webb.
Yeah.
Mike, what did you see?
Well, I can't sleep anymore anyway, now that I'm in my late 70s. So I did get up and I posted three. I hate to call them astrophotos because except for the moon before eclipse, they're not particularly clear, but they're on the RASC and Folio site if you want to have a look at them. And right after, just before 3 o'clock, everything went completely dark. So there was nothing else to see as far as I could determine.
Yeah, it started actually raining. So
yeah, that's what made Alex and I go home. Rain.
Yeah.
Randy, did you leave a brown chair, like a almost like a lawn chair that could fold up?
I did.
Oh, it's up at the center. We have it for you.
Oh boy. Yeah, no, it was not useful.
It was left outside. We found it in the morning.
Okay, so Mike, I'm looking at your photos and I see from the solar eclipse.
Last three posted.
Oh yeah. Or are they not in order? No.
I've got them.
I
If you want to
think
share.
I think the last one should be.
They go at the end, not
Yeah.
the beginning. I always move mine to the beginning, but they go at the end.
So it's down here.
Right at the end.
Okay. So I will share this, and you can talk. And David, David Lee, did you get any?
No, I just got shots of you trying to do crater timings. There's some variants of the one that you showed.
Yeah, you sent me another one, but you couldn't see the moon on it.
No.
Michael,
Okay.
This is like way better than we.
Well, at midnight, just a comment on that, Randy. I before I left.
Object of our affliction.
Oh, there it is. Before I left home, I think it was like midnight. It was almost perfectly clear, and then there's a huge halo around it. That's what I remember.
Yes, there was a halo. I took a picture of the halo before I left So yeah, so quarter second, 3200, and you got this.
You got a
So
little
that,
bit of the red,
yep,
kind of. You can see that.
Yeah, if you look real hard at it, you can kind of see the reddishness. And I pushed every slider to try to make that look like a real picture, but that's as good
yep.
as it goes.
Mm.
Well done.
Yeah.
Yeah.
Nice.
Randy, is there anyone else across Canada who got to do eclipse timing?
Deborah in the interior got a shot. Nice shot,
Deborah
actually.
Sarvolo.
Hmm.
Yeah, no, I haven't heard. Oh, Susan just asked, what's the implication of the moon halo? That is a whole talk in itself,
It
but
is.
it is super cool. When there are hexagonal ice crystals high up in the sky, then you get, is it a 8-degree ring or 15-degree ring? I forget but it's how the light refracts in these little hexagonal plates of ice. So it's not like a rainbow, but it's related. But
Yeah, there's actually a site called Atmospheric Optics that I always refer to, and they explain that. I can throw that in the chat.
Is it sundogs you're talking about?
well, it's related
there's all
to that
sorts of
too.
things. There's all sorts of things, but
So,
I think the halo is a very specific size because of the crystals.
yeah, the halo goes through the big flat surfaces, and the sundogs are when you're going through one of the little hexagonal surfaces. I think it's that. But yeah, it's quite amazing story. Okay.
And I see those periodically because of the cold temperatures.
Yeah. Okay. So Dave, you had a Dave Payne, you had a photo or something to show off.
Sure.
Yay.
Look at the share button. Okay. I do want to show off this image. I don't think I've shown it before. Yeah.
Oh, that's what's behind your head. I was going to ask you
Yeah,
what
that's
that
what's
was.
behind my head. So I just this is actually taken last summer, and I just processed it. It's a narrowband image of the Clamshell Nebula, and it's kind of archetypal for a stellar nursery. And what I mean by that is it's got a single star. Sometimes you see a cluster, but I think it's this single star right here where my cursor's circling. Started the whole thing going by it's a type O star, so it's the hottest, biggest kind of star, and it starts in the middle of a molecular cloud and starts blowing all these strong stellar winds as a bubble within the molecular cloud. And it's hot and a lot of doubly ionized oxygen because there's lots of very energetic UV associated with it, turns the center blue. Then it slams into the molecular cloud where it starts the oxygen, the hydrogen alpha glowing on the outer side. And then in the trailing, we see the red, and this is sulfur that is it's got the weakest of the ionization energy.
Okay. So what's your color mapping?
So that's the color mapping. The hydrogen alpha is showing in yellow.
Okay.
The sulfur is showing, which is the weakest and furthest away from the star, is showing in red. And the yellow and red combined are sort of giving the surface of the molecular cloud as it's being blown apart by the winds and the radiation from that single star. And it's causing additional stars to form throughout that cloud.
So this is way bigger than our solar system.
This is way bigger than our solar system. This star is thousands of the sun. That's that one star here. So it's way bigger than the solar system. But the reason for my showing it is because I just did a major posting on APRealSpace.com. So if you go to that website, my latest posting is talking about how gases express themselves so that we can image them, or astrophysically, how we can detect them and find out what they are. So and it's all through the interaction of light. So this is all about how gas expresses itself to us through visual light, stuff we can photograph, and how it astrophysically expresses itself. And I think if you got some time, I try to keep it not too high level science-wise. So I just explain, and there's one thing I want to point out, because it might change the way you think about the universe and within the galaxy. Let me just find this. I list here basically the four kinds of things, the four kinds of gases that make up essentially the Milky Way. There's that ionized gas, that atoms that have been stripped of some of their electrons, and they're buzzing around each other in a ionic medium. Then we've got, and so its dominant form of particle in that kind of gas is hydrogen atoms, the hydrogen ions, sorry, which are basically just protons, because they only have one electron. Then the next one is atomic hydrogen, that we tend to call neutral atomic medium, because it's hydrogen that's recaptured its electron. And this is the stuff that's really showing hydrogen alpha. It's hydrogen that's been ionized, and then it's going back to its atomic state. And then the final one, the one we're generally most interested in, is we call molecular clouds, or molecular medium, because those hydrogen atoms have joined together to form helium molecules. Those three gases take up essentially all the space in the galaxy. But I've listed here by volume how much they take up in the entire galaxy. Now, if we include the halo, ionized gas takes up 85%. But if you look at our neighborhood in the disk, it takes about 30% of the volume. 60% of the volume is that atomic hydrogen, which is generally invisible to us. It's not invisible to astrophysicists, though. And then 9%, or roughly 10% of the volume, is taken up by that molecular form. The molecular form is also invisible to us. It's also invisible to astrophysicists as well, but we can see the dust that carries with it. And that's how we identify a molecular cloud, is we look for the dust. By mass, it tells a different story, though. The 90% of the entire galactic mass is in that molecular medium, even though it takes a very small portion of the entire galaxy. And in fact, where you generally find that molecular hydrogen with its dust is in the spiral arms. And this other stuff exists within the gaps between the arms. But it barely takes up just over 1.5% of the mass. So it's very much rarefied. It's very, very light. But if you look at the last one here, that's all the condensed matter. That's the planets and the stars and everything like that. They only take up 7% of the mass of the disk. So when you talk about gravity and all this stuff, well, the stars aren't really, not even the black, it includes the black hole at the center of the galaxy. They're barely occupy any of the mass. It's mostly that hydrogen gas. And it's about only 3% of the entire galaxy. So that leads us to thinking of the entire galaxy is made up of stuff. There's no empty spaces out there. It's all different kinds of gases. So I hope that's enough of a teaser to send you to have a read. I'm happy to take any comments or suggestions. So please have a look if you've got some time. Talk about spectroscopy and molecular spectroscopy and how we detect these various gases and how they come up on our cameras. So that's all I have. Just a little
Wow.
promo.
Very
It's a lot
impressive.
of work, Dave.
Yeah, very impressive.
Yeah, it's fun work. We get to learn about all this website design, and as you can see, I'm probably still learning that part of it. But
Can you go back to your clamshell?
sure. So the feature here is the two main gases you're seeing here is that ionic form around this star, and that shows up as blue, and that yellow and red are showing the molecular cloud. Now,
But the black there is the dust, eh?
The black is, yeah, where the dust is particularly thick. It's been concentrated, and it's in the foreground. So if you can imagine, there's this glowing molecular cloud in the background, but it's trying to get to us, to our camera, but in parts it's blocked by thick dust that's been concentrated at the leading edge in places. So where it's shining bright, that bit of the cloud is actually facing this star, but where it's dark, we're actually seeing it's the backside of it, if you will.
Okay.
Where it's blocking the light. So it takes a bit of practice to start seeing these things in a three-dimensional form, because you have to divorce yourself from, while you're looking at it in 2D, you have to imagine it as a 3D form.
Wowzer.
There was someone asking a question, but I couldn't make.
I know that every time I look at that photo, Dave, I see something new in it. Down at about 240 degrees there, you can see a little cluster of stars, like a supercluster
Yeah,
there.
right
Yeah.
here.
Yeah.
Yeah. It must be much further away. You can zoom in on it. Right there.
Oh, look at that. Good eye, Wade.
Yeah. That is fun, just to take these images and go hunting for
And look at the variations in color.
Yeah. The color I tend to exaggerate a little bit. I tried to make it pop a little. But there's a little utility that you can run on these images, and once it's plate solved, it goes to the Simbad database. And the Simbad database is where all the astronomers and all the surveys, someone's gone through and identified and cataloged all these things. So you can actually ask Simbad to plot all those things on your image, and you can inquire what the heck is that. Sometimes there's more information than some other times, but
So Dave, do you actually calibrate the stars photometrically then based on the database?
yes.
Okay.
So sometimes you look at me and go, I don't know what the heck I think that's this, and you'll go and look what it up what is up. You're still just getting someone else's opinion, and you don't know how much time that astronomer spent looking at that corner of the sky as well. But it's usually confirms or denies what you thought. So it's fun to do.
Yeah, especially for objects that have known types of stars in them, that then it becomes very informative.
Yeah. And then it sends you down rabbit holes looking up how does that work and stuff like that. Okay.
Yeah,
Fantastic.
Thanks.
No other questions? Then I'm going to take the floor and talk about daylight saving time. Come on. There we go. Okay. Good. I got a laugh. You'd be surprised to know this actually isn't the truth. This was contrived. So before we talk about daylight saving time, we got to talk about time. And the important thing about time is it's all about where the sun is. That's what really drives us. People like to be awake when the sun is up and asleep when the sun is down. And when, for some of us, and and when the sun is highest in the sky and due south, that we call noon. And every longitude has its own noon. As you go around the world, you will have the time of noon shift. But that makes it really tricky when you're trying to catch a train. And in fact, the Canadian Sanford Fleming missed a train once, and it pissed him off, and he started a revolution. He conceived of this different system where every 15 degrees of longitude, so 15 times 24 is 360 degrees. Every 15 degrees of longitude would have its own time zone, and everybody working within a time zone would have the same time. But because people who are doing business together usually want to have the same time, those 15 degrees usually got manipulated a bit to cover whole countries or whole regions. So that was great, and it got accepted all over the world. But then some clever people said, why are we wasting all this time when the sun is up in the summer and we don't get to enjoy it in the evening? And there was this idea that it would save lots of energy. And anyway, it's interesting. It was in Canada. It was the first area that had daylight saving time, and it was up at the end of Lake Superior at what's now Thunder Bay. So they started in 1908, but then it was considered during the First World War that it would save lots of energy, and it was a way to help win the war, I guess. So many places started it during the First World War, and then they dropped it after and then brought it in again during the Second World War. But Canada has mostly maintained the twice a year transition between standard time and daylight saving time since World War I. And I remember in 73, I lived in Hamilton, and so I would watch Star Trek on the Buffalo stations, and they did a double daylight saving time. that might have been in 1974 during the energy crisis then. Anyway, it only happened that one year that there was a double. But I remember the television channels from the States being out of whack with the Canadian ones. It's important to know that it was not the farmers who said, let's do daylight saving time, because the farmers, they're going to listen to their cows. They're going to worry about when the dew rises. They do not care about what the actual clock says. So the whole idea was about the cities where people use most of the energy. But we are so decoupled from the clock now. People just run their air conditioners all summer and they drive whenever. And so it's been shown that it is a very marginal energy effect. So currently, and this is very up to date because you can see British Columbia is now off the daylight saving time. Saskatchewan's been, I don't know if Saskatchewan ever had it. No, it's the light gray. The dark gray, which are mostly equatorial, so they don't even notice the days getting longer or shorter. Sun rises at 6 in the morning and sets at 6 in the evening all the time if you're at the equator. So they never used. And these are the countries that are left. But as I imagine everybody knows, BC has now moved to eternal daylight saving time, which will be called Pacific time. I love this. They get all these kids at South Park School who are probably just learning how to read an analog clock, being told about that we're from now on going to be daylight saving time. Anyway, it has happened. And so now let's just take a look what this means. So first of all, were we to be very strict about the longitudes, then centered on 120 degrees west is 8 hours from universal time, from Greenwich, from England. But you can see that it doesn't follow the borders. And in particular, people in northwestern British Columbia would be different from the southern, and we didn't want that. Of course not. So this is the map a year ago, because British Columbia is still in half the time daylight saving time. Yukon already has made the transition. It's interesting. Creston. Has anybody been to Creston? I don't know if it's official or not, but they never changed time zone.
Yes, that was my old. I lived there I lived close to there for 35 years. Yeah, what they did, they never changed. What they do is they move the sign to change your clock back to Pacific time. So in the summertime, it is east of Creston, and in the wintertime, it is up on the big pass west of Creston. So
and it was just
move the sign.
But it was just the people in the city physically moving the sign and saying we're not changing.
Yeah. The highways department did it, and they call it Central Kootenay, so it's Creston and the surrounding farm areas. But yeah, there's a few communities. Yeah,
I did some field work there, and I thought it was like, why not? But it's just this one little town. Anyway,
keep in mind that the BC legislation gives local communities authority to declare whatever time they want to use.
Yeah, that map shows you, because of the angle, how eastern BC has always been like that as well.
Yeah,
like Dawson Creek's always been has never changed.
This guy Stefano Maggiolo has it's a weather website full of interesting things, but he produced this very nice map where if it's white, it means that noon is at noon. It's correct. Your solar dial will be just like real noon. So that is 120, where the Pacific Standard Time, so Universal Time -8, that's where the sundial is correct. But what has effectively happened is we are UT -7 starting yesterday and forevermore. And so you see that we're going to be over an hour. See, there's 1 hour is red. We're going to be more than an hour out of whack, and it's more like 2 hours when you're up in the northwest. So a point that this fellow is trying to point out is that most of the globe is actually red. People like to have their sun rising late and setting late is the general trend. Like it's a political thing, but that's what this is showing, is that there's much more red than blue on Earth.
So you're saying,
Now,
Randy, we need to adjust our sundials then too, right?
Oh, you better adjust your sundial. That's right. So let's just take a look. This is this guy Brian Brett Schneider, who also has a very good blog with a bunch of diagrams. So at the equinox, so this is in September and in March, then sunset is at 6 o'clock. Okay, and so the difference that you see here is you're seeing how far you are, like in that red blue map before. That's pretty well exactly what you see at sunset during the equinox. It says fall equinox, but it's the same with the spring. However, it's summertime, then those nice vertical lines are all put off because the Earth is tilted so much. And so take a look what's happening here. Normally, sunset, the summer solstice, okay, I'm just wondering, did they do UT -8 or UT -7 for this one? I'm not sure. But because the summer solstice is daylight saving time. So I think by local time, I think that's what they're saying. Yes.
Yeah, they have the markings. They have the markings. There's numbers there.
Okay, so, but it's very important that you see that some people get sunset at 1, 2, 3, 4, 5. There's 6 hours difference from 5 hours across British Columbia. And this is sunrise. That's interesting. It's not as big a change in the sunrises, the sunset, just because of the angles. That's interesting. But the winter solstice, this is where it's really tricky. So here we're not in daylight saving time when they did this diagram. And you see that, for where we are, it's going to be around 8 o'clock is when the sun rises. But come the next solstice, we're going to be effectively in the same time zone as here in Alberta. And so it's going to be between the green and blue. So it's going to be 9 o'clock is sunrise. And that's where all the controversy is people are going to be going to school when it's still dark. They will get more daylight in the evening. And so it's a trade-off. It's always a trade-off. So here we are. This is what time and date show. So for the last 3 months, well, last 2 months, we've been in standard time, and then we're in daylight time, and then, whereas everybody else is changing around Halloween, we're going to stay in daylight saving time. And what I did this box at 8 in the morning and 6 in the evening. And so you can see that last New Year's, we were right at sunrise at 8 in the morning. But come next New Year's, we will be in astronomical twilight, just before nautical twilight. So it's going to be dark. You know, it's going to be just plain dark as we approach the next solstice in the morning. On the other hand, I always know, you know, that first drive commute home in November, I always hate it because it was nice and light and then it gets dark again. It's in that one day we lose that hour, and we won't have that anymore. Now, this is the same diagram for up in Prince Rupert, and it's just a bit more extreme. You see they're way down here in the astronomical twilight. Actually, you know what? It isn't that very different. It doesn't look that very different, in fact. So it's about the same problem, Victoria, Prince Rupert. I thought when I looked at this the first time that it was going to be quite different. I thought it would be pure dark, but that would be further north. Anyway, this is a diagram that doesn't go into Canada, but I think it's a very good way of showing it. So days with reasonable sunrise defined by being 7 o'clock. And so, you know, we're here. So it would be, currently we're getting something like 200 days with sunrise before 7. Whereas now, we're in the bottom one. Daylight saving time, we're always in effect. And we're over here in the, 150 sort of range. So half the year now, sunrise is going to be after 7 in the morning. Sunset at a reasonable time defined as 6 o'clock. So you can see that it's almost all the time for us now. It's going to be, you know, up here over 300 days. So that is the astronomical reality of it. I thought I should bring this up because it seemed interesting. So there was 200,000 people across British Columbia answered the survey, which is pretty surprising. And it was resoundingly in favor of the staying to daylight saving time. Why? We don't get jet lag twice a year. That, for me, is the big one. I hate that. We get more, assuming that we keep the same schedule and we're not farmers going by the sun, we'll have more time in the evening with light. That's a good thing. In the winter months, it doesn't change the summer, of course. We don't have to do all those crazy things that happen going around your house, changing your clocks and all that. And more predictable planning. So those are the arguments. And I saw a post that Joe shared this morning. How do I stop my share? There we go. Joe had a post this morning saying how this is okay, but what we really want is have everybody use universal time. And that makes a lot of sense to me. But we don't have to, as a community, anymore worry about, are we UT8 or UT minus 7? Dave Payne has a question.
Yeah, I agree with almost everything that you showed. The one thing I don't understand is how it was justified in the first place. Now, you want it bright when kids go to school, when they come home from school, and I prefer it light in the evening than in the morning. But I'm sure this didn't win the war, as that one poster said.
So if you don't stoke up your furnace until the morning, and you get that in how does it work? Oh, somebody who knows about coal heating, help me here. It's supposed to save on your heating bills.
It's ramp time. Ramp
So
time for your heat to catch up to the cold house type thing.
okay, but why? How much would it save? Is it going to win the war?
Well, it's literally hours. Like a coal-fired hot water system, which is what I had in my house, would take 3 hours to come up to temperature for the house. And that's a lot of fuel. It's burning full bore for that time.
Why does changing in the summer? I mean, I totally agree with Dave's point. It's nice to.
Oh, it's bogus. Absolutely bogus.
It's nice to have the sun when you're awake. You're missing out if the sun is out when you're not awake. But I don't understand the other benefits. Dave really hit it on the head there.
Maybe to keep you out. I thought at one time to keep you out of the pub.
I mean, I can be flippant and just say it was a political decision, and as I said in my comment about UT time, get the politicians out of the decision process and just use UT, and then we were all saved from them. But I'll shut up now.
Think of how many times people have missed appointments on Zoom because they didn't get their time zones right. If we were all UT.
All of that aside, I'd like to interject a couple of comments. This goes back to stuff I looked at some 15 to 20 years ago. There was a bunch of research done on what's called seasonal affective disorder. And that's where your bioclock doesn't match your activity pattern during the day. Some people, there were some experiments done in a cave in France many, many decades ago, where they took melatonin measurements of people who were in the cave and plotted their bioclock to see what happened when they no longer had a daylight or a cue. And they drifted all over the place. There was some research done in Oregon that looked at people that had clinical depression, and they looked at their bioclock. And what they found is that some people were advanced and some people retarded their clock, their bioclock, depended on whether or not they had a light clue to their eyeballs that stimulated the pituitary gland that affected all your hormones.
Wow.
And what happens is that some people who are particularly sensitive to that early morning cue, their daylight clock goes the wrong way. So if you have a whack of kids that are going to school in the morning, they're not getting a daylight cue, and they happen to be those people that are retarded daylight clock, they're not going to wake up in the classroom till noon. Some people, it's physically debilitating. So I don't have all the stuff that I compiled 15 years ago, but there was a lot of work done on this, and this whole business of shifting the clock in the summertime shifting the clock in the summertime didn't matter because kids were up early in the morning anyway. But leaving it in the wintertime and daylight saving means they're going to get up in the dark every damn day in the winter. This is not going to bode well for school performance. No.
Okay. So you don't mind the fixed clock, but you would do it standard time.
I think there's good reasons to have a time shift to daylight saving.
Well, I agree with that, but what's the justification of switching it back and forth? Like that makes no sense.
Well, if you ideally you'd have it on standard time, and then you'd get the same daylight cues year round.
Yeah.
But what happens in the summer, in the winter time, if you go to daylight saving time, is those cues happen later in the day. And that's going to make a difference to the people who have retarded mild lungs, which is about 40% of the population.
Wow.
Yeah.
Laurie.
One thing I could add to that, I'm sorry about the people with their hands
Okay.
up. But in 1973, Richard Nixon changed, went straight to daylight savings time. And that only lasted 1 year. They reversed it due to public complaints about dark, dangerous mornings. The Russians also switched over to daylight time, and they had to switch it back because of the complaints from the citizens.
Okay.
They do listen to complaints from the citizens every once in a while.
But Richard Nixon was impeached shortly thereafter.
Not because of that, Reg. There were other issues.
And a back sure.
I mean, the whole reason for daylight saving time, particularly in Canada, was to allow us to have longer evenings with daylight to do stuff outside of the working hours. And it didn't matter with the bio clock because the sun was up early enough in the morning that if you got up at 7 o'clock to go to school, you were okay. But going back to standard time, it's not going to be as pleasant in the winter time. You're gonna have a bunch of kids sleeping at their desks.
No, if you stay on the daylight time,
If
you want to be on standard time.
If you stay on daylight saving time and have a bunch of kids sleeping at their desks.
Zombies.
Maybe
Laurie.
Maybe what we need is for school to start at a different time in the winters. It does
that would be probably preferable. Anyway, all this happened because standard time was to deal with the railways.
Yep. Laurie.
Every station have their own time, local time.
I was just going to say that a poll that they took back with the 223,000 people, it was, do you want to change back and forth? And people said no, they didn't want to change back and forth. Or do you want to go to daylight time? There was never an option of staying at standard time. Never.
Oh.
So there were only the two options. So your 223 people that said, yeah, let's do that. They agreed to not change the time, but there was never an opportunity to stay at standard. It was only daylight. And so it was really an extremely flawed poll.
Ah.
Even more so that the whole business of switching back and forth and how disruptive it is. How many people have clocks now that automatically do it? And they do. It takes me 2 minutes to set the 2 in the house that don't. Right. So what's the big inconvenience?
Oh, I think it's the jet lag.
Well, but
Gary,
jet lag, the way to fix jet lag is to get up when the sun is up. We found that traveling to Africa. We found that going to New Zealand. When we traveled to New Zealand, there's a hell of a time difference between us and New Zealand. Every time we went to New Zealand, we would stay up on the sun, and the next morning when the sun was up, we'd get up, and it would take 2 days, and we were on local time.
Gary, sit down.
If I got up at 7 o'clock, I'd be late for work most of my career.
Yeah.
Alrighty, changing the subject. Randy, I've always been fascinated with sundials.
Yes.
And I said to myself, I wonder how these suckers actually work, because you have an analemma that's not a perfect circle. It kind of goes crisscrosses. So how would you actually make a sundial to show you the real time?
Oh, okay. Well, the first thing is it's a tautology. The sundial gives you the real time. It doesn't give you civil time. It gives you solar time. So you're saying how could you have one that includes the equation of time? For the people who don't know about the equation of time, the Earth's orbit is elliptical, and there's it's the season thing. It's the going up and down, and it's the Earth is closer to the sun, so it is moving past the sun faster, slower. Anyway, it ends up that the sundial can be up to 15 minutes fast or slow. And there's this funny curve that anybody who uses a solar compass, which I do use for my work, you have to always take into account this equation of time. And then there's the 4 minutes for every degree of longitude. So that would be easy. You just have to turn the dial. Like you would not have noon where the sun is perfectly south. You would set the moon 4 minutes for every degree that you're away from. In our case, our reference longitude is 120. So we're at 123 or 124. So you're something like
13 minutes.
Thank you. Who said that?
Bill.
Bill.
It's in the Observer's Handbook. You can look it up.
There, well, yes, or you could just do it from first principles. But yes, it's 13 minutes.
I guess my question was, really, I didn't really ask it very well. If I wanted to know what the real solar time was right now, I'm thinking I would just wait until the sun's exactly north-south and turn the sundial so it's exactly on noon.
Yeah.
That would give me noon every day at the right time. But for the rest of the time around the sundial, we've now got nicely even spaced numbers. I'm sure that you could get it more accurate if you adjusted where those numbers were. Is that true or not?
Well, my sun compass, you set for your latitude so that the I forget what you call the plate, but it is parallel to the equator, and the gnomon is parallel with the Earth's pole. And then it's just arithmetic. It's 15 degrees every hour.
Oh.
If you put it flat, like your standard garden, then you have to space them a bit differently.
Oh, I see.
But
Okay.
yeah, if you orient it right, then it's straight arithmetic.
So if you put it at the right angle, it turns out to be right?
Yeah, I think I'd better do an Astro Cafe about sundials, eh? Is that what you're telling me?
That'd be great. Please. I'd love it.
There's a huge literature on it. Margie, your hand's still up. You're very patient.
It is, yes, because I'm still on the last topic.
Daylight savings time.
Oh, not jet propulsion.
No, not that one. Not that far back. So, what Dave Robinson said is exactly right. There is much research. I cannot quote it all to you by any means, but there is much research that says that being on daylight savings time forever it has profound negative effects. The most obvious negative effect is our circadian rhythms, which are attuned to light. And then there are other things like kids going to school in the dark and those things. And then there are traffic accidents and strokes. So
strokes?
Yes, strokes. So there are a lot of negative effects. And never in my life have I ever written to a member of Parliament. But I wrote to Grace Lohr the other day and said, I do not agree with this, and I would like a chance to actually have a say, because I did not have a say. Standard or daylight savings time. That's it.
Margie, can you elaborate on the stroke portion of it? Like how does that have effect?
I cannot.
Okay, I just found it was interesting.
Yeah, there was a news article about actually reports from emergency departments that they have a huge uptick in all sorts, not just strokes, but a lot of medical issues crop up during time changes.
Is that right?
Because of the jet lag, or because of
both ways apparently. But yeah,
I know growing up as a youngster, I grew up in the north. I was raised Fort St. John area, and going to school, caught the bus at 7:30 in the morning. It was dark, and bus home at 3 o'clock, and it was dark when I came home too. So we'd never seen daylight during school. Well, it was out during school, but you're indoors. But we amused ourselves anyways. As soon as you get home, you jumped on the snowmobile and you took off and you rode snowmobiles until all hours of the night. So
good for you.
I was in Whitehorse. I've been there a couple of times in the last number of years. And our guide said to us that in Whitehorse, because it's so dark there when kids are going to school, something like, I don't know, 10 o'clock or so, now I can't remember exactly what they did. I don't know whether they changed the city of Whitehorse's clocks or whether they changed the school times, but they changed one of those during the winter so that the kids could go to school in light.
Wow. Okay.
We are a tropical species, right? So where we evolved was it's bright at 6 o'clock and it gets dark at 6 o'clock.
Yeah. Yep. You're right.
So one of the easy solutions, if you have kids and you're worried about them going to school in the dark and not being awake, is when you get them up in the morning to go to school, sit them in front of a bright light for about 40 minutes. And that's enough to reset your biorhythm.
Hey.
And ask them why they didn't do their homework the night before.
Yeah.
But not a TV.
What a rich conversation that came out of this. I wasn't expecting that.
Well, in theory, they should have the extra hour the night before to do their homework. But
there you go.
This is going to be an interesting thing to see, when we get into that period where everybody else goes to standard time and we don't, and see whether we replicate what happened in the 70s in the States or whatever in Russia. And because I think there's a bit more politics in this decision that maybe should be.
And I think a year from now we're going to be changing. We're going to be changing back.
I just had an interesting thought though.
Change it to standard time. Yeah.
I have a bit of an interesting thought, and we'll see. I don't know. One thing that I'm critical about with schools today is how much kids are driven to school compared to when I went to school, or at least that's the way I perceive it. I may not be right. If there isn't an outcry a year for in the coming winter, that might be the reason, but we'll see.
That is a change.
But you go by a school, when it's coming in, and it's nuts because all these cars around and parents who are not the world's greatest drivers in these situations. So we'll see. It's fine to talk about school kids, but what if you bought a house that was partially built in the dark and everything's on a square because they do a poor job? I think there's another factor in there as well. So I predict boldly that we're going to be going back to the other time zone, and we might be also changing the premier as well because of that. I hope this.
I'll make another prediction that we're going to be endlessly complaining about this for the next several years.
Yeah.
I'm going to move us from the political realm to David Lee. We have to talk about our apparently vast store of very good optics, and vast store, even larger store of not so great optics.
Yeah, so you probably remember from few weeks ago, we talked about the our recent excavation. We have our own personal archaeological site in Sid's garage. And basically, let's see, let's have a look at the picture here. Now, this is substantially improved from previous times. Let me just get in here. So there you see us. This is a view that Marina took of us. We had a big crowd the first time we went out, so you see everybody kind of trying to figure this thing out. Now, we we made a valid attempt of finding homes for many of the more better scopes, and then we kind of carved out this pathway. Let me just zoom in here. We kind of carved out this pathway. Now, this was totally blocked until we removed a bunch of stuff. But I don't know. There's all sorts of stuff in there still. There's still many C8s and Meade equivalents. Most of them on, I would say most of them on fork mounts. Not many on equatorial. But there are a lot of legs and a lot of heads that are not joined together. So Brock had this brilliant suggestion of why doesn't the next session be a matching of heads and legs? So that's basically what we're gonna do. Let's see. So
why do we have so many?
I don't know. I don't know. I think maybe some people got rid of the tubes or people upgraded their legs. I mean, that's not an atypical situation where somebody went to a better mount, so they abandoned the mount and the legs. But I'll tell you, like for many of us, we may not have very nice legs right now. So this is a great opportunity to switch out your legs, like get bigger ones, right? And get a little bit more stability. But I'm hoping to get a number of equatorial mounts out of this because they become much more usable. And I'm even hoping that we'll find them such that we don't care about the electronics. The big problem with much of this stuff, it's aged. The boards are no longer available, and I'm not about to, or I don't know if anybody else wants to sort of fix boards at a component level, but that wouldn't be me. Uh, but yeah, maybe there's some simple things that could be fixed, but all in all, not really a good thing.
I could be
So,
interested in doing the board repairs.
well, if you want to, I mean, we may come down to that. At this point, we're just sorting out and picking out the stuff that's good, that's kind of working. Vince, you're coming in at the mirror making fixed last resort stage. In fact, I'll mention one more thing after this. So we will be doing that. That's the next phase. I think whatever we come up with, we're going to catalog. And this is kind of a warning to the whole community, a warning in the sense that we may be asking people to think carefully about giving a home to some of these scopes. Uh, so if you're interested in kind of upgrading, like if you have a smaller scope right now, have we got a deal for you? Now, another thing that came up, and I should mention this. Let's see if we can find this. I got a letter or I got an email last night, in fact, from a private owner, and they have more telescope parts and mirror making materials. And they asked us if we would be interested. So they're willing to just give those to us. But they also have a 9.25 inch Schmidt Cassegrain and a 90 millimeter Meade refractor. Now, Joe, have somebody contacted you recently? I don't know. Is Joe, you're listening?
Well, they just CC'd me. You just CC'd me, but they haven't contacted me, no.
Okay.
And I
So
haven't contacted them.
yeah, that's fair. That's fair. This is as I mentioned in a previous time. This is not atypical, and I suspect this is just the tip of the iceberg. We're going to get many of these kind of downsizing situations where people are going to give up their scopes, either by sale or just by sheer donation. So there's going to be a lot of them. Anyways, there's some opportunities here. I know that Kevin, when I mentioned this to Kevin Bertels, he said, well, why don't we make a sort of a group project for the beginners group and maybe take some of the pieces and assemble a scope. I think that's a great idea. I don't know how many people are game to do that, but that certainly could be a learning opportunity for us. But anyways, I thought I'd mention this just so that people are thinking. Um, if you're thinking of buying, maybe consider something that we already have in our catalog. I'm going to probably provide Joe with a catalog and we'll have sort of like matching pictures. And then right now, the only thing we have is we have a concept of a long-term loan. So, if you're willing to take a scope, you can have it on long-term loan. Now, we're going to run out of potential spaces. So I suspect we're probably going to have to look at liquidation as well. And we haven't thought that one out yet. We don't know what the fair way of doing that is, but you'll be hearing possibilities in the next couple of months. So
I would be interested in a few more scopes for my sidewalk astronomy, which I'm resurrecting. I used to do that in West Vancouver and Kelowna for quite a few years.
Yeah, a lot of us do that, Vince. I mean, I do it on occasion. If I have the forethought to do it, I'll go down to the breakwater and do different things. Yeah, there's a lot of pop-ups that happen just naturally. I know Bill Weir is famous for that. He'll just pop up in a grocery store area or Bill, do you want to comment on your sidewalk astronomy?
Well, I always have my solar gear in the back of my car. So if I'm somewhere and it's sunny, I'll just take it out because I live in a forest. So sometimes my horizons are narrow. And so I'll do it where I can, when I can. And if I can grab a stranger as they're going by, then they win.
Yeah,
That's
exactly.
sort of how it goes. And I'll stay as long as I feel like it. It may be a half an hour, it might be an hour. And I always do the market in the summer on sunny days. And I'm still recruiting for Bamfield or
Yeah, put your plug in, Bill. Vince, are you willing to take some of these extra scopes for outreach?
Yeah,
Or
absolutely.
oh, that's wonderful.
Yeah,
Yeah,
especially
then
ones that would lend them. So I'm actually good friends with the lady who runs RAD Society, which is Recreation Adapted Society.
okay.
And she's actually going to be working with me to make kind of these sidewalk astronomy programs accessible, wheelchair accessible, and
Oh, wonderful, wonderful. So you're probably interested in maybe some EAA kind of gear, like some cameras and stuff.
Yeah,
Yeah,
exactly.
I've got a deal for you too, because I've got some stuff kind of
Yeah.
sitting in the garage right now.
Having the camera lends itself well, especially if I can show like a live image sort of thing, rather than having people needing to come up to the eyepiece. You can have more people that can see things, but it also makes it accessible to people who are in a wheelchair who may not be all over the scope.
So Vince, I've been asked by the FDAO to put together maybe a talk about EAA, and but I'm just wondering if we could maybe at some point maybe get the community together up at the hill and maybe just talk about this type of sidewalk outreach in its various forms, right?
Absolutely, I'm down.
What do you think?
I'm absolutely down for that.
Okay, I'm gonna talk them into that because I think that's a great thing. I mean, in the age of smart telescope, there's a bunch of in-betweens, and I kind of want to talk about that. I don't want us to dump all this gear and just buy smart telescopes. I mean, we can make use of what we have, right?
And also with my machining background and access to machining equipment too, a lot of these scopes are like almost EAA capable. They just need the controller or brains or stepper motors or sometimes minor things to take them to the next level.
Excellent.
Like I just finished hyper tuning my EQ3 with belt drive and all that stuff.
Yeah.
And I love doing that stuff. And I've got literally buckets of servo motors and simple
Well,
motors.
we've potentially have lots of parts, and like it's a bit of a potentially it might be a bit of a puzzle. Like once we get rid of the stuff that we know is just good on its own,
Yeah.
we're going to get down to the stuff that needs some TLC, right?
Absolutely.
So I don't want them to go to the landfill. They don't have to. So
Turbo wave telescope.
let's maintain them if we
Yeah,
can.
absolutely.
Now, I have a request for our community. The 8-inch Schmidt-Cassegrain telescope is a classic. The one time I considered buying one, I decided it wasn't worth it. It was too heavy, and so I passed up this deal. But I would love somebody who loves their C8 to give us a talk about why. Is there
Well,
anybody?
I thought we would have a C8. Well, actually, Brock and I were joking because Brock's been telling me about the Leonard Nimoy specials because we've got a mix of orange and black. Well, the orange one, maybe Brock should tell the story, but the orange ones were famous at a point in time, probably in the 70s. In fact, that's a great idea, Randy. We should have a talk about the ubiquitous C8 because there's a lot of history there. A lot of history.
So some of my coolest astrophotography has been done on a C8. Like if you look at some of most of my images have been done on a C8, and I just love it to death.
Anyway, I guess what I need is a pitch for making space for it because they're bloody heavy.
I know. But they can be very manageable if you defork them. What makes them really heavy are the fork mounts, like if you I bet you in fact I'm doing this now. I'm putting my C8 on the harmonic strain wave mount, and that's a super light mount, right? But it will carry the C8. It's not a problem, right?
Okay, so this is a topic I'm not sure when, but I am very keen. And we've got, when you say a lot of C8s, more than half a dozen?
Oh, okay, help me with this, Brock. There must be at least either a Meade or Celestron versions. There must be at least 15 to 20. Wow. I suspect.
That's crazy.
It is crazy. Yeah. Yeah, it is crazy.
It makes my heart flutter.
Well, that's good. That's good.
Vince, make one of those telescopes made out of many telescopes.
Yes, the compound eye telescope. Yes, actually, you know what would be really awesome would be a binocular like a pair of C8 set up as binoculars.
There you go. Yeah, I haven't seen that yet.
That would be mint.
David, can you go back to your picture that is in Sid's garage?
Yes, I
for
can.
a minute.
Yeah, I can.
So I need you to look at the boxes. Like just even in front of you, there are 3 boxes kind of just all sitting there. There's one on the top, there's 2 over on the side, and there's probably another 3 whole sets of things even past and beyond that. Those are almost going to always be C8s.
Yeah, all
of this kind of stuff.
There may even be some 11s, like this one's bigger. These cases alone were worth a fortune in their day.
Yeah.
Like I'm not kidding when I call this an archaeological site because there's so much history here. As you peel away the layers, there's just so much stuff.
And you can't really tell, but there's at least three more levels, like 3 more whole sections behind where that is. And Vince, you can't even, you're not even actually looking at some of the stuff that we'd be looking at with you later on. Because you can't even see it.
The mirror making stuff is to the right. You can't even see that.
I would be like a kid in a candy store.
Yeah. Okay. So we've got stuff to give to people if people want long-term loans.
if there's a star diagonal in there somewhere,
There's many. There's many.
I desperately need one. I'm about to go spend $200 to go
No,
buy
don't.
one. So
Don't.
okay.
There is lots of stuff here. Lots of
Okay.
stuff. Yeah.
Because yeah, I
Well,
desperately need one.
Yeah, I mean, I'm really looking forward to getting the catalog together. I'm also hoping to put QR codes on everything so that we can have the spec and the ownership available. Like when we put these on long-term loan,
that'd
if
be
people
great.
want to know about them, they can just scan the QR and get all the info on it.
David,
So,
I have a question.
hmm.
Why are we talking about long-term loan? I mean, we need to get rid of this stuff.
Well,
We don't want to be in the loaning business.
I wanted to avoid it's only a first phase, Joe. I wanted to
Oh,
avoid the issue of fairness in terms of liquidation. Now
okay.
we're gonna broach that next. I've thought of a way of maybe a way of doing it. We certainly can't afford rent, so these things have to go, right? But then again, we want to retain enough, I guess, money from the liquidation to maybe support the VCO because the VCO, I wouldn't say is a money pit, but it does need money, right? And the things wear out, things get broken. Um, it should be self-sustaining, I would think. Like with these donations of equipment, if we liquidate or do different things with them, we can be self-sustaining in a way. We don't have to come to council for money. So I don't know if anybody has any questions about that, but you know, in some ways this is really exciting. In other ways, I get a headache from it.
Well, and it's sad that we had Sid as this huge resource, and we should have, while he was still here, done this process. But there you go.
We're here now.
I have one comment here. You know, we are getting a look at the future.
Absolutely.
I hope that what we do is recorded here, and it might actually make a very good and useful article for the Journal of the RASC, for the use of other centers who run into the situation we're in now. And
I really wonder whether this is unique, though, Chris. I mean, maybe
no,
Lori
that's
can
the
comment.
point. It's not unique.
Yeah.
I just think we might be a little ahead of the curve.
Okay. Okay.
And you know, that it might be useful for other people in other places. You know, and I mean, just yeah, I guess we wish we were a little further ahead than we are, but you know, I know, you know, we did start on this a year or two ago, actually, and so that's you know, one kind of silver lining on the cloud.
Yeah, you know, I kind of almost see an end in sight. I mean, I wasn't even sure what to expect when the doors opened, but I think it's doable. It's doable. We just have to find homes. In fact, I would love if there was somebody from the community that would maybe even scout out other potential homes outside of our community, right? Because that I don't think our club members are going to be enough to take care of the load, right?
Okay. And David, what are the requirements? Does it need to be heated?
Well, that's a good question. Most of these have been, I mean, that space isn't really heated as far as I know. As long as it's dry. I think that's probably the most important part. It has to be dry. I mean, we thought of getting like storage units, the ones that you can either rent or buy, but then you still need property to put them on, right? So I don't know. I don't know exactly where we're at. We
So
looked at
there is the
storage.
general request to our community. If you live somewhere where, especially if you have an outbuilding that's dry, that you'd be generous enough to house some of this equipment, that would be very appreciated.
Yeah, wait, let's get the catalog first, and then we know what we're dealing with. I mean, for all we know, and Brock and I will probably assess this. For all we know, maybe a lot of it is just junk, right? Like it's not really salvageable, but we'll see. I'm hoping not to get rid of more than we need to.
I have my storage shed out back, and because I keep my telescope equipment in there, I've got the mother of all dehydrators running in there.
Oh, okay,
And
cool.
I keep it at a pretty consistent 25% humidity. So I could probably with if I get rid of my motorcycle, my set I have two motorcycles. If I get rid of my second motorcycle, I'll have a lot more space for telescopes. So that's
Yeah.
more motivation for me to sell that bike.
Well, that's great, Vince, and there have been other people in the community that have made offers as well, and then I think some things have been already put on long-term loan. In fact, I have a 127 Mac that I have on long-term loan now. But I think as soon as we figure out what the liquidation policies are, I may end up buying it. So we'll see.
So
Very good.
When's the next time there?
22nd of March. I don't think we're going to need a lot of people there, but what are you thinking of, Bill? Bill, are you
I'm
there?
just looking at my calendar now.
Oh, okay.
I may still be in Tofino.
Oh, okay. I think Brock and I should be able to handle it. I think Chris Purse is coming out as well. We're just gonna try to pair up mounts and legs mainly, and then continue documenting and creating the catalog. So then we'll see what we're dealing with, right?
This is an amazing service you're doing for the community, you guys. It's fantastic.
Yeah.
Okay. Yeah, we're coming to an end. So just some announcements. Is that what your hand's up for, Lori?
Yes, I was just a quick announcement that has to do with Sid. Is there is going to be on the 20th, which is a Friday night, 20th of March, there is going to be a star party up in the Highlands that Sid was the one who kind of did that and would have it for the Highlands people. There might be 20 to 30 people up there. If there are some people who would like to come up, we'd love to have you come up and maybe, we like maybe 6 or 7 telescopes up there if we can, and just have a nice evening of looking. I'm going tomorrow to go and look at the site to see whether or not things are all right. But I will let you know a little bit more. So just if you want to just kind of keep that 20th, if you're interested in helping out with the first annual non-SID Highland.
Such a lovely thing.
It's the Sidhu
anyway,
Memorial.
Sid's memorial
Yeah.
fling. There we
Well,
go.
I'll tell you, I'll really miss Sid on Astronomy Day because he did so much with the solar group out front of the museum.
That is a great segue, David.
I offer that to you, Randy.
So yesterday, Ben, Lori, David, and I had a first talk about International Astronomy Day 2026, April 25, Saturday, April 25. And the names here are all not official yet, but let me just say that we need, like, Ask an Astronomer, we need astrophotography, we need solar telescope people, the welcome desk. So when the call goes out, I don't want you to be surprised. And this is our second biggest outreach event each year after the Saanich Fair. And it's super fun. And we like to have many participants. All levels of knowledge and experience are welcome. Okay. Any other announcements before we say goodbye?
There's a program at the UVic.
Oh yes,
yeah, Wednesday night. Yeah,
on Wednesday. It's a good one. It's
Vera Rubin.
Vera Rubin. Oh, I wish I could go. So go see it. Talk about the Vera Rubin telescope, which is it's still not started. It's LSST, Large Survey of Space and Time, something like that. But it's close. It's already doing not announcements. They're called
alerts.
Alerts. Thank you. Anyway, the telescope is working. It's amazing. And the notice has just been put in the comments. Margie, potentially the last thing of the evening. What is it?
And I think Bill wants to speak as well.
We also have Bill.
And on Wednesday night, there's a new person who is responsible for making sure that the microphone works. The microphone and is attached to a person who is speaking. Guess who that is?
I'm looking at them. I'm looking at her.
It is I. Yes. Yes. So I am Madam Microphone starting on Wednesday night. And we're just going to make sure that everybody can hear.
Way to go. So did I hear that Bill has something to say?
I didn't fully get my plug in for Banfield.
Go for it.
So May 8th to 10th, they will give us accommodation. We might need to double, or depending if there's a female there, triple in one room. They will give us accommodation. They did say that. So it's 8th to 10th. Really, it's the 9th and 10th. We're doing solar in the day, a little star party thing on Pachina Bay Beach at night. Pretty much all of the official activities are taking place in Anakla, so the First Nations community. And it should be fun. So I'm really looking for 1, maybe 2 more people. So I've got CJ who's interested, and Ben Dorman is going to help. And I could use probably 1 more person to come over. So it's a beautiful place on this island. If you've never been there, it's just worth it for going over for that. I'm doing a thing for the Friday night with the Banfield Community School. I don't really need anybody else's help for that, unless you want to be. I mean, I'm not excluding anybody, but it's something that I've sort of put together with a youth who I was building a telescope for, and then he went and bought one on his own for himself. But now I'm going to be donating the scope that I put together to the school, because he works with the school, and so he'll be there to be able to help them out with it. So
fantastic. Bill, this is such a good thing to do. Thank you. While you're at it, tell us again about Beavery.
Oh, the Beavery is, I'm trying to think what date that is. The last Saturday in May also. A few people would be useful for that to come out. And really, it's just doing solar stuff. Even if you don't, and for the Banfield thing, don't think you don't know enough. You know 99.9% more than anybody that's going to be showing up on average. So really, if you don't have a scope, I have all the scopes. If I know that I need to bring more scopes, I can bring more scopes. And I'll bring all the solar stuff that might be needed. Unless you have your own, then bring your own. So the same, and the Beavery, I'd be able to supply enough solar scopes to make it work between what the club has and what I have access to. I can get stuff from Pearson, and I have a few things that live in my car. And that's a fun one. The kids are so enthusiastic.
That's so good. And with that very happy note, I say good night to everybody.
All right.
Good night.
Take care.
Right.